Ah, beautiful, guys. Amazing, amazing, amazing. Yeah, some of you guys have like interesting emojis. Interesting. Bridget just put a heart, like a pulsating heart. I need that emoji to make sense. Like some of these I understand, but some of the others, hey. Okay. Excellent, guys. All right, let's get started on today's lesson. Today we're going to be speaking about exponents. Okay, so I'm going to ask some basic questions. And these questions are basically what we would call the laws of exponents. Let me just add a few lines over here, right? So what we usually know about exponents is actually called the laws of exponents, all right? So when we talk about the things that we're doing, they're actually laws. They've been proven to work. So if we think about some number A, we don't know what the number is, but it is raised to the power of 3. And I multiply that by the same number A, and I raise it to the power 4. What do I know about my number A? What do we know about the exponent of my number A? What will it be? Good, Adiba. Well done. Excellent. It's going to be a to the power of 7. My exponent is going to be 7. And we know this actually comes from the idea that if I have like bases, and they're being multiplied, I need to add exponents. I need to add my exponents. Okay. I need to add exponents. Excellent. Now, if I have some number A, I don't know what it is, to the power of 10, and I divide it by A to the power of 8. Same number. What will I get? I will get, my base would be the same. I would keep my base, and I would subtract my exponents, and that would be A to the power of 2. So when like bases are being divided, I'm going to subtract exponents, but I'm not just going to subtract exponents, guys. I'm going to subtract top minus bottom, okay? Never the other way around. I could never do bottom minus top. And if your teacher has told you bottom minus top, it's because they want you to keep the bigger answer at the bottom, not at the top. Okay, so we always minus top minus bottom. And I'll show you what I mean as we go along. All right, let's look at another one. If I've got some number A to the power of 3, and all of this is to the power of 3, what is this going to give me? I'm going to keep my base, and what's happening to my base? Good, my base, or my exponents are being multiplied. Okay. Good, but we're not actually multiplying, guys. I know that this should be 3 times 3, which is 9. What we're actually doing is we're raising 3 to the power of 3. So what we technically have here is A to the power of 3 times A to the power of 3 times A to the power of 3, which ends up giving us A to the power of 3 plus 3 plus 3, which is the same as 3 times 3, which gives us A to the power of 9. Okay, so these two things are actually the same. Okay, for those of you who are having issues with audio or who are having issues with seeing the screen, I need you guys to DM teacher Simone, please. Okay. DM teacher Simone, and she'll be able to help you. Okay. All right. Let's talk about some letter A to the power of 8. The square root of some letter A to the power of 8. I'm going to have A. I'm going to keep my base, and then what's going to happen to my exponent? Good. I know I'm going to get A to the power of 4, but what did we do to the exponent? Did we just minus 4 to get A to the power of 4? Good, that's what he said. So we divided by 2. So we divide the exponents, not by whatever number we feel like. We divide the exponent by the root. We divided by the root. Okay, so we know that if this thing is just a root sitting on its own, there's actually a tiny invisible 2 over here. So what we've actually done is we've taken 8 and we've divided it by 2. And that has given us 4. But that's not actually what's happening, guys. That's not exactly what's happening. Here's what we're doing. Any number, if I call it x, if it sits under a square root, this is actually x to the power of a half. And I know that if I already have an 8 there, a half of 8 is going to give me 4. Now, I'm going to ask you guys, if I've got the cube root of x, this is going to be x to the power of 1 over what? 1 over? Good. Abu, not 2 anymore, because now there's a cube root, this is going to be 1 over 3. Okay, same as if I said I've got the 4th root of x, no worries, no worries. Okay, this is going to be x to the power of what? Not 4, Karabo. I didn't give you the 1 this time. You have to give me the whole thing. Good, that's it. Abu, you see, you got it right this time. Excellent, well done, Theo. That's it, Homoto. Excellent. This is going to be 1, x to the power of 1 over 4. So when we actually do this, that invisible 2 over there, what's happening is we are taking this a to the power of 8 out of the square root, and we're rewriting it as a to the power of 8 multiplied by the power of a half. And a half of 8 will give us 4. Lutando and Ari, where did I lose you? Can I ask you guys to put your hands up so that I can help you where I've lost you? I don't want to leave you behind. Hands up and let's have a chat. Yes, Prince. Oh, Prince. Okay. Okay, explain to me exactly where it is. I haven't quite explained it to you properly and where I've lost you, so we can have a conversation about it just so we don't get lost. Hello, Kamogelo. And Lerato. Okay, I just want to make sure everybody else other than Ari and Lutando, can you give me a thumbs up if you understand everything else that I've written? Okay, so for Ari and Lutando, if I said to you, what is the square root of 4? Everybody can actually answer this question. What is the square root of 4? Not 4 squared, the square root of 4. Which number multiplied by itself twice will give us 4? It's 2, correct? It's 2. So when we say we've got a tiny little 2 here, this is what we mean. Because we know that anything underneath a square root is x to the power of a half, this thing over here is actually the same as 4 to the power a half, right? But I can rewrite 4 as 2 squared. 2 squared times that a half that we already had. Now, half of 2 is going to be the same as 1, which is the same as 2 to the power of 1. And I'm going to end up with 2. Right. We can even try it with the square root of 9. What is the square root of 9, guys? Which number multiplied by itself is going to give us 9? Good, it's 3. Now I can rewrite this because it's under a square root. I can rewrite it as 9 to the power a half. Okay, and then I can take 9 and I can rewrite it as 3 squared multiplied by that half that was already there. And a half of 2 is going to give me 3 to the power of 1, which is the same as just 3. Okay. Mulebogang, when you say, ma'am, what does that fit represent? What is the fit? the dot. It means multiplication. Thank you, Khumutso. The dot means multiply. Okay, the reason we do this, the reason we use a dot instead of a multiply is because in maths, a lot of you guys do this. You're like, I would write x times x times x, and I know that's x cubed, but some of you guys write your x's like this. So imagine if you wrote x times x times x is equal to, what are we exactly doing here? See, so in order to differentiate between the x that we use as a variable and the multiplication, we put a dot instead. Okay, and that tells me that's x cubed. Okay, that's why we use the dot instead of the x now, because the x that we use for a variable and the multiplication sign, they start almost looking like the same thing, and we don't want any confusion. Okay, excellent. Good question, by the way. I don't think enough people ask that question. Okay. All right. I'm glad everybody's on the same page. Okay, let's use some of these things that we've just looked at, on the laws of exponents. And remember, guys, all of these exponents, things that we've talked about over here, they also apply to numbers. Do not think just because ma'am used an A, it means they don't apply to numbers either. All of these apply to numbers as well. Okay, here's what I mean. I'll give you an example before we continue. If I said to you guys, I have 3 to the power of 4 multiplied by 3 to the power of 5. What is this? This is, don't punch it into your calculator. Give it to me in exponent form. These two things have the same base. My base is both 3. So I'm going to keep my base. Well done, Sepang. That's it, 100%. I'm going to keep my base 3, and then I'm going to add my exponents. 3 to the power of 9. That's it, Tammy. Well done, Jason. Well done, Samkelo. That's it, 3 to the power of 9. Okay, so just because sometimes we're using A's and B's and X's doesn't mean these things do not apply to numbers as well. We need to make sure that we can see them in numbers as well as in letters. Okay, well done, guys. Excellent stuff. Good. Now, let's look at our first exercise. Okay, we're going to start here. Now, it says, simplify each of the following. Leave your answers as a power. Now, let's start over here. Number 1.1. 1.1. Yes, Boyzo. I hope I'm saying the name correctly. I hope I didn't make it.
Mama, I just wanted to answer the question.
Yes, absolutely. I'd love to have you answer the question for me. So what are we going to do? What's our answer going to be?
I think it's going to be a to the power of 4 plus a to the power of 4.
Good, but you're not done. Okay, you're right. This is going to be a to the power of 4. Let me just rewrite it again. 1.1. Okay, I'm going to go 1.1. A to the power of 4 plus a to the power of 4. But we're not quite done because there's still a multiply. There's a multiply there in the middle. So what is our final answer? Not a multiply, sorry, an addition. So what are we going to have in the end?
A to the power of 4.
Not quite. Not quite. Let me ask you this, Boyzo. If I have an x sitting all by itself, what's the variable in, or not the variable, the coefficient in front of x?
1.
1, good. So we know that any variable sitting on its own has a 1 in front. So this one actually has a 1 in front of it, and this one has a 1 in front of it. Right. So I'm going to ask you again. What is my answer over here? A to the power of 4, 1a to the power of 4 plus 1a to the power of 4 is going to give us what?
2a to the power of 4.
Beautiful. We're just going to count how many a to the power of 4s do I have? I have 2 of them, correct? So this becomes 2a to the power of 4, and you did that beautifully. Very, very well done. Nicely done. I want you to put your hand up again later on so you can answer another question for me, okay? All right, okay. Does everybody understand why the answer is not a to the power of 8? Yes, give me a yes in the chat if you understand why this is not correct. Okay, Remember, guys, the only time we add exponents is if there's a multiply in the middle. Okay, so if there's not a multiply in the middle, then we cannot do that. As soon as they put a plus sign in the middle, what we need to think of when we see plus and minus signs in algebra, we need to think of like terms. We need to think of like terms. Okay, so we need to make sure that when we're doing this, we are doing it one after the other. And I can re-explain 100%. All right, so this is a multiply sign, and BODMAS dictates that we, give me 1 second. Okay, BODMAS dictates that we do multiplication first. So I have a to the power of 2 multiplied by a to the power of 2. I can see that these two things over here have the same base, so I can keep my base and I can add exponents. So I'm going to keep my base a, and I'm going to add my exponents. 2 plus 2 will give me a to the power of 4. So now I've dealt with these two, but there's still a plus a to the power of 4, plus a to the power of 4. Now my next operation is a plus. So when we look at a plus in the middle, what we need to think of are, is this and this a like term? Are they both the same looking term? Do they both have an a as a base? And do they both have the same exponent? Yes, they do. So we just add them together. Okay, so I've got an a to the power of 4, and I add another a to the power of 4. How many a to the power of 4s do I have? I have 2 of them. Okay, so that's what we're looking for when we talk about exponents. Okay, so I've got 2 a to the power of 4. All right, give me a thumbs up if we're all okay. Hi, Fatima. Hello, Fatima.
Ma'am, I do not understand. Why did you leave the 4A?
Which 4a?
The Ascari it's 2, I mean A, then to the power of 2 times A to the power of 2, then plus A4.
I didn't leave it behind, my sweetie. What is a to the power of 2 times a to the power of 2?
They add so it's 4.
Yes, it's a to the power of 4. You see that one? That's the one I wrote over there, right?
Okay.
But this one is still also there. That's why I rewrote it over here as well. You see that?
Oh, as the final step.
Yes. Okay, I took both of them down. Okay.
Yes, ma'am. Bye,
You're
ma'am.
welcome. All right. Okay, I'm going to check if Oguhle has a question. For those of you who understand, please try 1.2 and 1.3.
Hi, ma'am.
Hello, my sweetie. What's up?
Ma'am, I wanted to ask that if we have a minus 2, do the opposite way.
Yes. Yes. So let me ask you this, Oguhle. What is x plus x?
X to the power of 2.
We are adding. I have an x and I add another x. How many x's do I have now?
Oh, 2x.
2x. Good. I'm adding them together, right? I'm counting.
Yes.
This is how many I have. Almost like we're counting things. Remember in grade 1 when they taught us this, John has 3 sweets. That's how we count.
Yes, ma'am.
But if I say to you x times x, what's the answer there?
Oh, it will be x to the power of 2.
Exactly. Do you see the difference in the operation?
Oh, yes, ma'am.
And this one is a multiply.
Multiply.
So
Yes,
we always
ma'am.
need to
Thank
ask
you.
ourselves, Oguhle, what operation are we doing? And then we'll be able to see it. Okay.
Yes, ma'am. Thank you, ma'am.
You're very welcome, my sweetie. Well done. All right, guys, keep the questions coming. Love to see them. Okay. Oh, look at what I did now. What did teacher Kukuru? Give me a second. All right, try 1.2 and 1.3. If you've already got an answer for me, I would love to have a conversation with you about how you solved for it, and we can chat together. Okay, if you've got an answer for 1.2, I'd love to chat with you. Hi, Corey. Bukhari,
ma'am.
if you give me an answer like that, I know that you've used your calculator. Okay. But oh no, not technically. Technically not. But let's see if you went where I went. Yes, Corey, what's up?
Ma'am, first we have to break down the 5:2. No, ma'am, we
Okay.
start by the brackets first.
Good. Why would we start at the brackets first, Corey?
Ma'am, board mass.
Ah, that's it. Good. BODMAS says that we start with brackets. So I'm going to leave the 5 to the power of 2. I'm going to leave the 5 squared there. Let's figure out what's happening inside these brackets. Okay. Okay. What's happening inside?
Ma'am, 3 to the power of 4, we break it down. So the answer will be 12 minus.
Not 12, not 12. Remember, Corey, there's a difference between 3 times 4 and 3 to the power of 4. Remember, 3 times 4 will give us 12, yes. 3 to the power of 4 is the same as 3 multiplied by itself 4 times. So 3 times 3 times 3 times 3. You have to do it 4 times. Okay. So you'd have to tell me, what is 3 times 3 times 3 times 3? Quick maths. Have you figured it out yet? If you're stuck, everybody in the chat is helping you out. Okay.
Ma'am, 81.
Good. It's 81. Good. 81 minus. Now, what about 15 to the power of 0?
Ma'am, it's going to be 1.
Beautiful, because we know anything to the power of 0 is
1.
good, is 1. Okay, so let's continue. Now I've got 5 squared multiplied by 81 minus 1 would give us
80.
good, 80. Okay, technically, Corey, we can stop here. Okay, and the reason why I'm saying we can stop here is because the question said leave your answer as powers. Leave your answer as a power.
Okay.
So we don't actually have to continue. Okay, but if we did continue, this would give us 25 times 80, and then people would start pulling out their calculators and give me an answer. I see you guys. But we're going to leave the answer just here where we've left it. Okay, thank you very much, Corey. You did that excellently. Remember the difference between 3 to the power 4 and 3 times 4, okay?
Yes, ma'am.
Excellent. Good stuff. Siamtanda, do you have an answer for me? Or do you have a question for me? Other Siamtanda, the other one. Whew, we're going to have to figure out which Siamtanda is which Siamtanda. Hi, Siamtanda.
Ma'am,
Yes.
can I do 1.3?
Absolutely. Yes, let's do it. Okay, what did you get for 1.3?
1.3, I did negative 11 to the power of 2 plus 121 because you're timesing 11 by itself twice, which would make it a positive.
Good. Well, we're timesing negative 11 by itself. But remember, Siamtanda, they're telling us to leave this in exponent form. Okay. So we're not going to make it 121. We're just going to leave it as positive 11 to the power of what? Positive 11 to the power of?
2.
2. Excellent. Not done. What is negative 11 squared minus plus 11 squared? What would that give us?
Negative 11 squared plus 11 squared is 0.
Beautiful. Ah, excellent. 0. That's the exact answer I'm looking for. Well done. Panda. That's the one I'm looking at. Okay. Thanks, Siamtanda. Beautifully done. Excellently. Amazing stuff. Okay. Somebody's asking me, why is it positive? All right. Here is why it's positive. If I said to you guys that I've got 2 to the power of 3, 2 to the power of 3 is the same as 2 times 2 times 2. But remember that there's a positive here and a positive here and a positive here. Okay. So when I have to put the signs together, a positive times a positive times a positive is going to give me a positive. And then 2 times 2 times 2 is going to give me 8. 2 times 2 is 4, times 2 is 8. So this is going to give me positive 8. Now, if I say to you guys, I have now got negative 2 all cubed, what this actually means is I have negative 2 times negative 2 times negative 2. Okay, Slindile, can you explain to me what's going to happen with these negatives? What are these negatives not going to give me? What are the negatives going to give me in this case?
Ma'am, can you explain again?
Okay, what's a negative times a negative?
It's a positive.
Good, and then the positive times a negative will give me?
Negative.
Good, so I'm going to get negative, and then 2 times 2 times 2 is going to give me? Calculate quickly, 2 times 2 times 2.
Eight.
I'm hearing calculators going, and you should be able to do this without clicking our calculators. Good, it will give us 8. So we will get negative 8. But very well done, Slinjile. Okay, so for those of you who are like, but why isn't it negative? Okay, this is why. Because that squared tells me that there are 2 negative 11s. So I'm going to have negative 11 times negative 11. And a negative would give me a positive, and 11 times 11 would give me 11 squared. Okay, so that is why we ended up over here with positive 11 squared. Okay. Offensive, what do you mean it's not in exponential? Do you want to put your hand up for me, please, Offensive, so that I can just understand what your question actually means, so I can explain a little bit better? Okay, everybody else, 1.4, 1.5, 1.6. Go for it. Okay, and when you're done, put exactly 1 emoji in the chat, your favorite emoji for me, please. Okay, Tando, what's up?
Hello, ma'am.
Hi, Miss Reading.
Ma'am, I'm actually ready to answer 1.4.
Ah, beautiful. Can I ask you to just hold on for me? Don't put your hand down, Tando. I'm going to speak to you in just a second. Okay.
Okay, ma'am.
Excellent. Molebogang, do you also want to answer a question? Just nod for me if you want to answer a question, or you can do this if you want to ask a question. Okay. All right. I'm going to unmute you and you can ask your question. Okay.
Ma'am,
Yes.
I wanna do 1.5, but I can't understand this bracket.
Oh, okay. Okay. So I'm going to, let's do this. I'm going to ask Tando to help me with 1.4. And then when we do 1.5, I'm going to call on you again. So don't put your hand down. Okay.
Okay.
All right. Excellent, my sweetie. Tando, are you ready? Let's do 1.4. Hi, Tando. Hi, Tando.
Hello, ma'am.
Hi. Okay, there
Oh,
we go.
sorry, ma'am.
No worries.
Yes, ma'am. Anyway, so 1.4, 5. So we're gonna start with the brackets first.
Good.
Then 5 times 5 times 5, which will give you 125. And
But
then
remember, Tando, they want you to leave your answer using powers. Okay. So how do we rewrite 5 times 5 times 5 using exponents?
5 to the power 3, if I'm right.
Good. Absolutely.
Yeah.
You're good. And then we get divided by, and then what happens here in the square root of 125? I mean, the cube root. The cube root of
so ma'am, I got an answer of 5 when I did it. So will the thing be 5 to the power 1, or is it 5 to the power 3?
It's 5 to
I
the
wasn't quite
power
sure.
of 1. No, you are 100% correct. Okay, this cube root of 125 would give us 5 to the power of 1. Let's break this down. Let's break it down, Kando. Remember we said that the cube root is the same as 125 to the power of a third. Remember that cube root makes this a power of a third, yes? Do you remember I said that at the beginning, or were you here when I said that?
Yes, ma'am.
Okay,
I guess
cool.
I was
Now-
here when you said it.
Okay, good. So when we take 125, I can rewrite 125 as 5 to the power of what? 5 to the power of?
5 to the power of 3 or 1.
Good. 5 to the power of 3 multiplied by a third. Okay.
Yes, ma'am.
So that's going to give me 5. What is a third of 3?
A third of 3 is 3. I'm doing mentally here, ma'am.
That's good. You should be able to do it mentally. Okay, so if there are 3 of us and we break a pizza up into a third of each piece, how many pieces do each of us get if we break it up into 3 pieces? How many pieces do we
each
each
get 1, ma'am.
Good. So a third of 3 is 1.
1, yes, ma'am.
Yes, good. A third of 3 is 1. So this answer that we got over here, 5 to the power of 1, absolutely correct. Okay.
And ma'am, I kept on doubting my answer.
No, absolutely. It is correct. You did it correctly. But you're not done, Tando. I have like bases and they're being divided. What do we need to do?
Sorry, ma'am. We need to divide now.
Good. So we're dividing. So my bases are the same. I'm going to keep my base. What am I going to do with my exponents?
I'm just going to leave them there.
Like bases being divided, we're going to
I'm gonna.
check in the chat.
going to
Everybody's helping.
subtract them. I mean,
Good. We're going to subtract. So what's my final
subtract
answer?
them, ma'am.
Good. My final answer would be 3 minus
2, ma'am.
Good. It would be 2. 3 minus 1 will
3
give us 2.
minus 1, which is 2.
Beautiful.
Yes, ma'am.
Okay. And that's the answer I was looking for in the end. I guarantee your calculator gave you the same answer, but your calculator probably said 25. Yes?
Yes, ma'am, it did.
And if we were marking a test, me and your teachers would be like, because we asked for it in power form. We asked for it in exponents.
Yes, ma'am.
Okay, so we've got to get used to doing that.
Yes.
All right. But I love this interaction with you, Tando. Please put your hand up again if you want to answer another question. Okay. Molebogeng, are you ready? Let's have a look. Oh, Khomozo says she has a question. Then we'll look at question 1.5. Hi, Khomozo.
Hi, ma'am.
What's up?
Ma'am, so the method that you did at 1.4, I
Mhm.
did another method, but then I got the same answer.
Okay, so what did you do?
Ma'am, I said 5 times 5 times 5, which gave me 125, right?
Mhm.
And then I put in the 125 and then said divided by the cube root of 125, which is 5. And so it was 125 divided by 5.
Mhm.
And then
What
I
is
got
125 divided by 5?
25.
Mhm.
So I put in the 25 and then I put 25 as I put 25 as 5 to the 5 squared.
5 squared. Okay. But
Yes.
again, even though your answer is correct, Khumto, we cannot give you the mark. Okay, because you haven't quite the rule that we're looking for. Okay, rewriting 5 times 5 times 5 as 125 shows me that you did mental math and you didn't actually use the rule that we wanted you to use. So even though your answer is correct, if this question is worth 3 marks, we can only give you 1 out of 3.
Oh, okay. Thank you, ma'am.
Cool. All right, let's have a look at 1.5. Molebogeng, my sweetie, I'm going to do this one very quickly for the sake of time, okay? And then we'll come back to the next one. All right, we're going to come back just now. All right, so we will note here, guys, that we have brackets inside of brackets inside of brackets. Okay, so it's kind of confusing when you don't know what to do with brackets inside of brackets, right? But the thing to do is to work inside out. Okay, that's the thing that's going to help us out here. We're going to work inside out, right? So I'm first going to tackle the inside brackets, and then I'm going to tackle the outside bracket. So I'm going to leave my square brackets there, and I'm going to work with the brackets on the inside. Now, remember what we said, guys. We said that if this is -4 all to the power of 5, this is the same thing as -4 multiplied by itself 5 times. So I'm going to have -4 times -4 times -4 times -4 times -4. I hope my math is correct. 1, 2, 3, 4, 5. Good. So what we're actually evaluating here isn't the 4 to the power of 5. What we're evaluating is the sign. Okay, so we're looking at this. What is a negative times a negative times a negative times a negative times a negative? Multiply them over and over. Do they give me a positive or do they give me a negative? What do they give me?
Negative.
Good, they give me a negative. So I'm going to end up with -4 to the power of 5. That's what I'm going to get. So in this first bracket over here, I'm going to get -4 to the power of 5 multiplied by, now let's do this next one over here. This one says -4 squared. So that's just 2 of them. That's -4 times -4. What's going to happen to my sign? Will it be negative or positive? Good. Yes, that's it. Kutuano. Excellent. It's going to be positive. That's it. Lerato. Good. So I'm going to end up with positive 4 to the power of 2. And all of this is still going to be squared at the end. Now we are not done, guys. We still have this multiply here in the middle. We have that multiply in the middle. I can hear somebody else is still unmuted, guys. Please remember to stay on mute. Okay, stay muted, guys. Okay, Theo, do you want to tell me, let's work through this next part together because I'm seeing, okay, Lebring's hand is gone. All right, Theo, are you there?
Yes, ma'am.
Excellent. All right, so we're going to do this in a bracket. Okay, we're still working on the inside. Okay.
Yes, ma'am.
But I know that I'm going to get a negative times a positive. What's that going to give me?
A negative, ma'am.
Good, a negative. And then I'm going to notice that I have like bases being multiplied. So what am I going to do?
You're gonna first multiply 4 times 4, then you get 16.
No. Remember,
Plus...
we must always keep the base. What is my base?
The 4, ma'am.
4. Good. So we must keep 4. Okay. Do not multiply them together, Theo. Okay. We always keep them the same. All right. And then what do we do with the exponents?
Don't you plus them?
Absolutely. Yes, we plus them. So I'm going to end up with -4 to the power of
7.
Beautiful. This is still squared, Theo. It's still squared. So
yes,
what's going to happen here? Now I've got -4 to the power of 7 all squared. I'm not done. Let's keep going. We know that this squared tells me that I've got -4 to the power of 7 times -4 to the power of 7. What's my answer going to be? Start with the signs. What's going to happen with my...
A negative and a negative gives you a positive.
Beautiful. So I'm going to have positive. And then I notice that I have like bases being multiplied. Am I going to multiply my bases together, Theo?
No.
No, absolutely not. No. So I'm going to keep my base, right? My base 4. And then what am I going to do?
You're going to plus the 2 exponents.
Good. And how much am I going to get?
14.
Beautifully done. 100% just on the money. Well done, Theo. Amazing stuff.
Thank you, ma'am.
Very nice.
Thank you, ma'am.
Sure. Okay, cool. And that was a tough one. I feel like that one was like, yo, my way. Pumzile, do you want to do this next one with me? Let's do 1.6. For those of you asking brain break, guys, I'm so sorry. The time it's like, it's here. It's here, guys. I'm so sorry. Okay. Well done, Keegan. Amazing. 1.6. Okay, Pumzile, are you there? Hello, Pumzile. Pumzile, unmute. Oh no. Oh. Nico, do you want to do 1.6 with me? Now Pumzile unmutes. Oh, Pumzile. After now,
Sorry,
call someone else. It's okay. Hi, Pumzile.
Hi, ma'am.
Hi. Okay. All right. Do you want to do this last one with me?
Yes, ma'am.
All right, excellent. Okay, so what are we going to get over here? What do you think, Pumzile? I want you to note, Pumzile, before we continue, that this number over here has a base of 8, and this number over here has a base of 4.
Yes, ma'am. I'm aware of it.
Are they the same base?
No.
Okay, good. I'm just checking if you've seen it. Okay, tell me what to do.
Ma'am, I found 8 squared, which gave me 64. And then I say 4 times 3, it gave me times 64. Brackets. And then we say divide by 64.
Okay, this is not going to give us 64. 4 to the power 4 is not going to give us 64.
Oh, I thought it was a 3.
And the problem we're having right now, Pumzile, is that you're doing the exact thing I told Khomoto not to do. We need to keep looking at this using powers. So we need to use exponents. Okay, so what I actually wanted for you to notice is that 8 squared is in fact 64 times 4 to the power of 3, which is also in fact 64. So what we can do is we can take 8 squared and we can rewrite it as 4 to the power of 3 because they're both the same thing. Okay, they're both the same thing. So we can take 8 squared and rewrite it as 4 to the power of 3 times 4 to the power of 3 in brackets divided by 4 to the power of 4. Do we think we can continue with the sum from here? I think the sum gets a lot easier when we see it here. Boyzo, do you want to tell me what we would get?
Oh, ma'am, can you ask the question again? I didn't really understand.
Can you finish off this question here for me? What are we going to get?
4 to the power of 2.
Okay, but you need to explain to me step by step. Okay, don't skip steps. Otherwise, other people are going to be like, huh? Okay, tell me, what did you do to get 4 to the power of 2?
So firstly, you're first gonna minus because so you're gonna get 4 since they're the same. You're gonna say 4 to the power of 6, and then 4 to the power of 6 divided by 4 to the power of 4, which would give you 4 to the power of 2.
Good stuff. Excellent, because we're dividing and the exponents would minus. Well done. Excellent work, Boizo. Very well done. Okay, then you go. Don't go away. I want you to answer another question for me. Guys, unfortunately, we're not going to have a brain break. I'm so sorry. There was so much work to get through. Look at all the work I thought we were going to get through. It's just everything took a little longer than we had thought it was going to. Okay, Deniko, are you there?
Hi, ma'am.
I'm not going to erase. Hi, my sweetie. How are you doing?
Fine, thanks, and you, ma'am?
I'm good, thank you. Do you want to answer 1.7 with me? Okay.
Ma'am, I wanted to ask a question about 1.5.
Okay, no worries. Okay, tell me.
Ma'am, you separated the two numbers, -4 to the power of 7. Ma'am, do you have to do that, or can you just times within the brackets?
you can times within the brackets, right? The only thing there is that you're going to have to remember to change the sign. Okay, my sweetie? Because even if I do this,
Yes,
even if I
ma'am.
take the 2 and multiply it with the 7, it negates the fact that this 2 will also affect that negative over there. Okay.
Yes, ma'am.
So we just need to be very careful about that. But if you're able to do that all in one fell swoop, go for it. Okay.
Okay. Thank you, ma'am.
Okay. Theo, do you want to answer this last question for us? Let's look at this. Remember, now you don't have to use powers anymore. Okay.
Okay, ma'am.
All right.
Yes,
do you want to
ma'am.
do this one for me? What is 49 minus 36?
13, ma'am.
Ooh, check again. Check your mathematics. Oh no, yes, you're correct. I'm the one who's wrong. You in my brain, Theo, I'm saying 11 because 49 is 7 squared. How? Okay, yes, it's 13. Good. So inside the bracket, we have 13 all squared. What is 13 all squared? You write it over here.
169.
Beautifully done. Excellent. I don't want you to go because I think that one was too easy. Let's maybe do 1.8 as well. Okay. Let's look at these ones over here in the middle over here. So I've got 5 squared times 10 cubed, right? Multiplied by 15 to the power of 0. Where would we start with this kind of question, Theo?
Won't you start by the 15 to the power of 0?
Good. What do we know about 15 to the power of 0?
It is going to be 1, ma'am.
Good, this is 1. So we're not even going to evaluate that part. We're only going to look at this thing here in the middle, right?
Yes,
all right,
ma'am.
so how are we going to evaluate this thing here in the middle?
Aren't we gonna first times the bases?
Good, we can, but are they the same base?
No, ma'am.
No. So can we do anything with the exponents together? Can we multiply them together?
We can plus them.
We can't plus them because they don't have the same base. We can't plus exponents. We can't multiply the bottom. No, we can't do anything. Okay, so we have to evaluate each of them separately. So we have to start with this one and then that one. Okay.
Yes, ma'am.
All right. So what is 5 squared?
25.
Good. 25 times 10 cubed is
1,000.
good. It's 1,000. Good. So that 3 just tells us how many zeros come after the 1. Right. So that just means we're going to put 3 zeros here. And then
yes, ma'am.
Times 1. Good. So what is 25 times 1,000?
25,000.
Times 1.
It was 25,000.
Good. 25,000. That's it. Well done for you. Excellent work. Very nicely done.
Thank you, ma'am.
Awesome stuff. Very, very nice. Okay. Guys, I think we are out of time. I don't, which question is this? Please tell me which question that is for, 1.7. Okay, I'll have a look in just a second, but not quite. And I'll explain why just after this. Teacher Simone, can I ask you to run the pace poll for me, please? While I take Siam Tanda's question, because we have quite run out of time. Hi, Siam Tanda. I'm looking at Siam Tanda's mom or dad's very beautifully polished table at the moment. It looks very expensive, something very stealable. Hi, Siam Tanda.
Hello, ma'am.
Hi, Masiri, what's up?
Ma'am, I have a question on 1.7.
Yes.
Ma'am, since it's like open bracket 49 minus 36 and close bracket, and there's a 2 outside, shouldn't it 49 minus 36 brackets and then open the brackets again and put the same thing?
Well, yes, and you will get the same answer. Okay. Here's why. You're going to get 49 minus 36 and then open another bracket with 49 minus 36. Yes?
Yes.
What is 49 minus 36?
49 minus 36 is 13.
Good. That's the first bracket. And in the second bracket, what is 49 minus 36?
13.
Good. So I still end up with 13 times 13, which is the same as 13 squared. And that is equal to
169.
169. Do you see how we get to the same conclusion?
Yes.
Maths comes full circle. Do you see that? Like, even if this was x plus 2 and we did x plus 2 bracket x plus 2, it still works even if we just use numbers. Do you see that?
Oh, okay.
You're very welcome. It's a good question. It speaks to the understanding of the logic behind mathematics. So very, very nice question.